Now we are up to number 9. Number 9 deals with buying an ice cream cone. They gave you 10 flavors and 3 scoops. I went down to 9 flavors. I wanted to change the numbers a little bit. Went to 4 scoops because it's ice cream. Why not buy another scoop? 4-scoop ice cream cone might be inconvenient to eat, but I'm pretty sure we've all tried it once or twice. Anyway, I have a couple of issues with this that kind of sort of need to be addressed. One of them is whether or not you care about the order that you get your ice cream scoops in. And you might. If they're in a bowl, you can pretty much eat from whatever flavor of ice cream you want. If they're in a cone, you don't really have that option. Right? So you might care about the order. This doesn't allow that. I might just love their Dutch chocolate and I might go for it in all 4 scoops. Who knows? Right? So if you buy them all from the same flavor, they're assuming you're not going to. They're assuming they're all going to be different flavors. No, yeah, it says different flavors. May not be what you do when you buy, 2 or 3 or 4 scoops of ice cream at your favorite ice cream shop. Right? But assuming that you do not repeat your flavors, and this is assuming we do not care about the order. I'm going to write that, because that'll change things a little bit. Those of you who have done combinatories will be saying that sounds pretty simple when they make those assumptions. And you'd be correct. I'm going to logic the way through it and then give you a formula sort of approach first off. For this type of stuff, for counting methods, when you get a word and, you pretty much always want to replace it with a multiplication. The word or is pretty much always going to be an addition. And you can convince yourself of that fairly quickly by thinking in terms of waking up in the morning on a winter's day, and if you have 3 pairs of socks and 2 pairs of shoes, if you want to put on both socks and shoes, first pair, second pair, third pair of socks, from each of these you have 2 different options for your shoes. Gives you 6 different outputs. 1, 2, 3, 4, 5, 6. So you'd multiply those if you're doing both socks and shoes. If you just want something to keep your feet warm and you don't really care whether it's socks or shoes, you got 5 items you could put on because you would add those. So I want socks or shoes, or means you'd add. Socks and shoes, and means you would multiply. That's what you do here. We're buying a first scoop of ice cream and a second scoop and a third scoop and a fourth scoop. So we're going to multiply the number of ways of doing these. So I have the flavors. If we have 9 flavors, I have them written down there, flavors A through I. If I'm doing 4 things, I'm just going to draw a line. We're doing a first thing and a second thing and a third thing and a fourth thing. So I want to do the number of ways of doing the first thing multiplied by, because we're doing a first and a second, multiplied by, and a third, and a fourth. We're going to multiply those number of ways together. And I'm just going to pick one of those flavors and say, maybe we start off with flavor B. Question isn't what flavor do we have, it's how many options do we have. Right from the beginning, we would have 9 options. We'd have the number 9 multiplied by, well, once I've removed the number B from it, or the flavor B, can't choose it a second time because we're not doing replacements on this. So once I've removed it, it only leaves 8 things. So I'd be doing 8. And maybe I did F for that one, right? Maybe I look up there and I'm like, well, once I've removed F, I really like flavor G, so I grab it. Well, there's 7 options there. And you can kind of see we're setting this up as what's called, I don't know, last one was I, right? So this looks like the beginning of what's called a factorial. And it is. A factorial would just be 9 times 8 times 7 times 6 times 5, all the way down the list till we get to 1. All right, that's a factorial, right? And that's what we're starting, but we're not finishing it. What we're leaving off to get there, if I'm stopping at 6, then these ones have to cancel away. And that kind of means that we'd be putting a 5 factorial on the bottom. Like that, right? So if we do that, those cancel. We're just left with 9 times 8 times 7 times 6. And this is what we'd actually have for a formula for what's called a permutation, right? 9 factorial over 5 factorial. They usually use the letters N and R. This would be N things in a permutation, right? Be written that way. We'd have a 9 factorial divided by 5 factorial. Problem is, I said first scoop and second scoop and third scoop and fourth scoop. This question doesn't mention whether the person cares about the order or not. But if I'm doing a first and a second and a third, BFGI, I treated this different than I would have if it were FBGI, right? Because the only way that I get the 9 out of this is by saying I can choose all of those. This thing here, if I just did 2 items, I'd be getting 9 choices and 8. I'd be getting these as being different items, different things. If I'm doing a first and a second and a third, I'm implying an ordered approach, right? So I want to go one step further with this, and I want to say if the order does not matter, how do I get rid of the orderings, right? So this is the order matters, would be a permutation. Permutations and combinations are basically the ways of figuring out how many ways you have to do things if you are selecting from within a set, which is what we're doing. We have 9 flavors of ice cream. If we are selecting from within a set without replacement, and by without replacement, it means I can't walk in and say, I want 2 scoops of chocolate, 1 of French vanilla, and 1 of strawberry. I can't do that. I can't double up on the scoops of chocolate, right? No replacement. Those are going to be a combination or a permutation. Permutation is if we care about the order, and that would be this formula. And for us, it would be a 9 factorial. We're choosing, let's see, 4 scoops. It'd be divided by, oops, my bad on that, sorry. I just blew that. N minus R. 9 minus 4 would have been a 5, so we would have been doing this, right? So permutation would be that. That's if we care about the order. This question kind of implies that we don't care about the order. If we don't care about the order, then I have to divide by the number of arrangements of the 4 items. So if I know I'm choosing items B, F, G, and I in any order, then I'm basically saying arrangements, that I'm choosing 4 things, 1, 2, 3, and 4, and I'm trying to figure out how many ways to arrange them. I'd have 4 choices from my first, 3 from my second, 2 from the third, and 1 for the last. That's just the 4 factorial, right? So when I don't care about the order, it's the same exact thing, except that I have to divide by the number of ways of ordering the items that I chose. Number of ways of ordering the items that I chose is just the R factorial. For the example I gave up here, we would have had the 9 factorial on top. This is called a combination. And in a combination, if I just look at my numbers, I got a 9 on top, a 5, and a 4 on the bottom. The 5 and the 4, if I add them together, it equals 9. That's a 9. Combinations, the sum of the 2 things, the numbers you have on the bottom, always equals the number on top. So that's what we'd have for this thing here if I don't care about the order. And if I figured this out, just going to grab my calculator real quickly because I might as well. 9 factorial divided by 5 factorial is going to be 9 times 8 times 7 times 6. Divided by 4 factorial is 24. This would be 126. For the one I just gave, when I changed the numbers a little bit, I'd have 126. For this one, it would have just been 9 factorial divided by 5 factorial, and that's going to be 24 times as large. Many more options on the permutation, 3024. So if I care about the order, we get a little bit more than 3,000 ways of doing it. If I don't care about the order, 126. And that's because rearranging it gives you more options that matter to you. Now, if I only have 2 items If I only have A and B and I'm choosing them both, if the order doesn't matter, that's the only way to do it. Because if the order does not matter, these would be the same thing, so I was redundant. A, B, B, A, well, I already wrote it, it's over here. If the order does not matter, then these are the same, right? So if the order doesn't matter, that's the number of ways of choosing them both. If the order does matter, then those are different, and I have 2 ways. So an ordered approach is going to give you more possibilities. Ordered is called a permutation, that's why it's got the P there, and you get a bigger answer. Combination is what they're assuming in this. I'm going to double check that before going on. But I'm pretty sure they do a combination in this. 10 and 3, number 9. I'm going to double check before sending on. Yeah, they assume the order doesn't matter in this one. They gave different numbers, but it should be easy enough for you to figure out. They gave you 10 flavors and 3. So if you do a 10 and a 3, you're going to have a 10, a 3, and a 7. Well, that is one of your answers. That's answer choice A. So anyway, that's what you do for these. Again, combinations and permutations, only if you have a set of things and you are selecting from within the set without replacement. That's what they did here. The replacement here would be saying, well, I chose chocolate for the first scoop. I put that option back in, and I chose chocolate for the second scoop. If you can double up on that thing, it won't be a combination or a permutation. So anyway, that was number 9.